is a, well, that was a weird noise. This is a kind of refresher lesson on rational functions from Algebra 2. And we reviewed some of this at the very beginning of this year as well in Unit 1 when we talked about parent functions and transformation rules. So you'll notice it says graphing reciprocal and then it says rational in parentheses. So rational functions are when we have x in the denominator. They're called reciprocal function. The parent function is the reciprocal of your just linear function, y equals x, because reciprocal just means flip the fraction, right? So if I flip x, it becomes 1 over x. So the parent function is the reciprocal function. But once we start making transformations and adjustments to that, I'm going to typically just refer to this as the rational functions. So you can see this is the parent function information. This is stuff that you should know, okay? Kind of refresh your memory. This is what the graph looks like. You can see that it goes left forever, right forever, but there's this break. It's not continuous. It's a discontinuous graph. What is this called here? This vertical line that we can't see that breaks the graph up? Y'all remember? It's like these sides are approaching it, but will never reach it. An asymptote. Yeah, and same thing's happening vertically. If we look at the range, like from bottom to top, it goes down forever, it goes up to forever, but there's a break in the middle here. Okay, and so for this parent function, those asymptotes are at the x and y axes. Okay, there are no intercepts. The parent function doesn't cross the x or y axis. And again, the domain and range both go on forever in both directions, but there's that break at 0. So it's everything but 0, essentially, for the parent function. The type of graph this is called a hyperbola. I don't think y'all got to a unit called conics in Algebra 2, so that term may be new to you. But it's these curves going in opposite directions of each other. That's a hyperbola. The transformation rules, if you recall from the beginning of the year, we reviewed transformations. We said that the form would be a over x minus h and then plus k is not in the fraction. You may also see this instead of a being written in the numerator, a could also be written out front, being multiplied by the fraction, okay? And it would just be a 1 as the numerator, okay? But if we multiplied that a in, a times 1 would just be a for the numerator. So that a value is going to stretch or compress the graph. And if it's negative, it's going to reflect the graph. The h value, that's what we consider inside the function because it's in the denominator with the variable. Remember, it's the opposite direction, left or right. So if it's x minus a number, it's actually to the right. It's shifted to the right. If it's x plus a number, that's actually going to shift it left. And then the k, this is the value being added or subtracted outside the fraction. That's your vertical shift. Okay, so plus a number is going to shift your graph up, minus a number is going to shift your graph down. Okay, so that's a review of those transformation rules. And you'll see if you're shifting left or right or up or down, that is shifting your asymptotes, your vertical and horizontal asymptotes that are starting at 0. So this horizontal asymptote is the line y equals 0. If I have a k value moving my graph up or down, that asymptote is going to move up or down with it. So it's going to change the equation of that horizontal asymptote by whatever k is. Same thing with the vertical. The vertical asymptote is this vertical line at x equals 0. And if we shift our graph left or right, that asymptote is going to shift left or right with it. And so it's going to become x equals whatever that h value is. That's going to be the location of the new asymptote. Feel okay about that? Okay, so like I said, that's kind of just a refresher. Back in Unit 1, we reviewed all the parent functions and transformation rules. So we're going to start, I'm actually going to flip over. We're going to start on the over here with this one that says example 1. So flip to the back real fast. In example 1, it asks you to identify the asymptotes, the domain and range, and then graph the function. Okay, so here I'm going to start by identifying that A, H, and K in this equation. Okay, so the A value is a 3, which it's positive, so it's not reflected, and it's greater than 1, so it's going to vertically stretch our graph, but that's not going to do anything to our asymptotes. Okay, so it's a vertical stretch, but no reflection, and that does not affect where our asymptotes are. That does not affect our domain and range. What's going to affect the domain and range are the H and the K. So H is what's being subtracted from X in the denominator here. So if it's plus 2, that means H must be negative 2, because it would have to be minus negative 2 to become plus 2. Is there anything added to the end of this fraction on the outside? So K would be an understood 0. So what this tells me is that I'm going to actually write this side by side. So H is negative 2, which means my graph is shifted to the left 2. So that vertical asymptote that was at 0 is now at negative 2. So I'm going to sketch that in my graph. I'm going to write that. My vertical asymptote is at X equals negative 2. The K being 0, that means I haven't shifted up or down any. So my horizontal asymptote is still here on the x-axis, which is y equals 0. So this is the shift of the asymptotes. It's just to the left 2. Now the curves, remember in the parent function, there's a curve in the top right quadrant and the bottom left quadrant created. And that's only going to change if you're multiplying by a negative. That's going to flip. Okay, and there's no negative here. So I know there's going to be a curve in the top right quadrant and the bottom left quadrant. They've gone ahead and given us a little table of values. You can create your own table of values if you need to check points. So the easiest point to check is probably 0, because if you plug in a 0, that's 3 over 2, which is 1.5. So at 0, 1.5, there's a point. If I plugged in a 1, I would get 3 in the denominator, which 3 over 3 is 1. So there's a point at 1, 1. Okay, and you can check multiple points. Okay, but I'm just going to plot those two, and then I know the asymptotes are guiding my curves. Okay, so I'm just going to sketch through those points, and I'm going along the asymptotes forever. I'm going to approach them but never reach them. Now, if I pick a point to the left of this asymptote to see, well, should the curve over here be above or below? I'm going to pick negative 3 as the x value. If I plug in negative 3 plus 2, that gets negative 1. 3 divided by negative 1 is negative 3. So that means there's a point at negative 3, negative 3. So I know that my curve must be in this quadrant here. And so then I'm just going to use the asymptotes to guide that curve and go through that point. Now my domain is everything except the vertical asymptote. That's the break in the graph. So my domain can be written as all real numbers, but x cannot be negative 2. It's based on that vertical asymptote. The range is based on the horizontal asymptote. The range will be everything, but y cannot be 0 because that's where there's a break in the graph for the y values. Now you can write your domain and range like this, or you can use interval notation. Interval notation, we would say left to right for domain. It goes from -infinity to -2, and then there's a break and it picks up again and goes from -2 to infinity. So we can use 2 intervals with the union in between. That's the domain as well. Okay, so that's another way you could write the domain. The range would be the same thing. You would pick up from -infinity, because it goes low to high for range. So -infinity up to 0, that's where the break is, union, and then 0 to infinity. So either one of those in blue and green, I would accept for ways to write your domain and range. Y'all feel okay about that? Okay, let's try example 2. So again, I'm going to identify my A is -1/2. This time there is something happening. What's that negative going to do? What's a -A going to do to my graph? It's going to flip it. It's going to reflect it over the x-axis. And then the fact that it's 1/2, it's less than 1, it's between 0 and 1, that's going to compress it vertically. So this is actually going to be reflected and vertically compressed, but the vertical compression we're not real worried about. What is my H value? Yeah, it's going to be a -1 again because we have a plus. So remember, it has to be the opposite sign. And then my K value is that -3. So what that tells me, the H being -1 tells me that I'm shifting to the left 1. So that asymptote that's normally here at 0 is shifted to -1 from the parent function. So I have a vertical asymptote at x equals -1. The K being -3 means that the graph has been shifted down 3. So that asymptote that's normally at the x-axis is down at -3 here. Okay, so we've got this -3 for the horizontal asymptote. Now notice I'm always writing the vertical asymptote as x equals and the horizontal asymptote as y equals. Those are equations because these are lines. It's not just a number. You should write it as x equals a number for vertical asymptotes and y equals a number for horizontal asymptotes. Okay. Now, before I even sketch this, go ahead and grab that paper as you come in. That's what we're on. As I go ahead and before I even sketch this or know where the curves are, I know that it's going to go left and right forever. And so I'm going to go ahead and write my domain as everything except that -1. Or what's the other way I could write that? -infinity to -1 union -1 to infinity. And notice we use parentheses there, not brackets, because that -1 value is not included in the domain. My range, I know is going to be everything except y cannot be that -3. You'll grab that paper as you come in. So in interval notation, that would be -infinity to -3, union -3 to infinity. Now I do need to graph this, so I still need to plot some points. So if it's helpful to you to make yourself a little XY table and get some points to check to the left and right of your vertical asymptote. So I'm going to check 0. So if I plug in a 0 to this equation, I get a 1 in the denominator, which dividing by 1 doesn't do anything, right? So it's -½ minus 3. So that's -3.5. Just going to write it as a decimal. So -3.5. So there's a point at 0, -3.5. So that's right here. So I can see, oh, my curve's going to be down here in this little quadrant created. So then I'm just going to use the asymptotes to guide my curve and go through that point like that. I could have probably drawn that curve a little better. Okay, now I'm going to pick a point to the left. So if I pick -2, if I plug in -2 plus 1, that's -1. A negative divided by a negative is positive. So this becomes +½ minus 3. So that is -2.5. So there's a point at -2, -2.5, which that's in this top left little quadrant created by those asymptotes. So then I can use that to guide go through that point and use the asymptotes to guide the curve. Feel okay about that? So this practice at the bottom, 1, 2, and 3 here are just like what we did there. We want to sketch it. We want to give the vertical and horizontal asymptotes, and we want to give the domain and range. So you're doing the exact same process I just did in those 2 examples. And if you go back to the front, I initially skipped these because these are actually a little easier than that. The graph is already drawn. What I would like you to do is go in and sketch where that asymptote would be. That's not going to ever be drawn in there. If you look at it in a calculator, you're not going to see these dashed lines, but it helps us to visualize and see the equation of our asymptotes. So when I'm given the graph, I can see this vertical asymptote is at x equals -2. I didn't even need the equation to see that, right? But doesn't it make sense because it's x plus 2? The vertical asymptote's at x equals -2? Because that's what would make that denominator 0. That's where the function did not exist. Okay, the horizontal asymptote we can see has not moved off. Oops, that doesn't look like a y. It has not moved off the axis. Grab that paper over there as you came in. Okay, so my asymptotes, I can label those and then just give the domain and range. The graph is already done. So that's all you have to do on those. Feel okay about that? All right, and then I will post this completed one. So once you try these 3 on the front and these 3 at the bottom on the back, you'll be able to pull up and check and make sure that you've done those correctly. There's no additional practice, there's not a Delta Math or a quizzes or anything today. It's just these notes, and then we're going to do a couple more days of notes. This is really a refresher review of what you should already know about rationals, and using this basic format where you can see your shifts. You'll need that paper as you come in. I set over there. What we're going to get into in the next couple days is looking at it when the equation's in different formats, when it doesn't have the k separated out of the fraction and things like that. And maybe there'll be more than one x in your equation and how that's going to affect it. So we'll get into more complex equations tomorrow, but for now, just this refresher. Make sure we remember all of these basics from Algebra 2 and from the beginning of this year.